to PASC26. This is the highlights from the conference. I am here with Prashant Kanduri from Swiss National Supercomputing Center, ETH Zurich. Prashant, in this edition of the PASC conference, you have organized for the first time an industry session, and your industry session was on non-GPU accelerator technologies in scientific computing and machine learning. Can you tell us a little bit about this session?
Yeah, so like you said, this is the first time that PASC conference had an industry session. And I mean, it's like we want to build bridges across multiple disciplines, make transdisciplinarity happen. But we also saw that many of our sponsors from industry had a lot of interesting research going on. And we thought we could have an interesting dialogue if researchers from there could talk to researchers from academia, and so that we could also get a little teaser of what's to come, so that these gaps could be bridged a bit better.
But what were the highlights from your discussion?
Yes, so we had 4 presentations totally in this. So the first presentation was from IBM Research, and they spoke about a quantum accelerator. So, I mean, and the reason why we focused on this topic, non-GPU acceleration in the first place, was because, you see, GPUs have become so expensive now. And it's no more, we also have an economic reason
to look for something else.
Exactly.
Yes, alternate technologies.
Absolutely,
yes,
absolutely. And also that GPUs are not the right hardware for a lot of problems that we need. And the new hardware can potentially have promises of orders of magnitude of disruptive leap. So in that regard, IBM's presentation on quantum accelerator showed one such promise. And most of the quantum research is actually happening here in Switzerland, in the Ruschlikons Research Center. And ETH Zurich collaborates closely with that too. And yeah, I mean, he presented some very promising use cases in drug discovery, which and what quantum can do today. Not something
that is more concrete results. But then, Prashant, I would like to ask you, what are the challenging for us to collaborate with industry?
The challenge is that, firstly, we don't talk to each other enough. That's the first thing. Or we stick to ourselves in one bubble. For a long time, CSCS and many other computing centers have been working with a set of vendors. And their perspective is also limited by what those specific vendors have been able to offer. But there's been a lot more innovation going on outside of that as well. And one of the things that came out of those discussions is that public research institutions can potentially be a little more experimental, try new kinds of hardware.
So you partially maybe also answered the final question that I will ask you. What would you like to see happening now? I mean, you started this dialogue with the industry, but then what would you like to see happening in the coming months and maybe until the next PASC conference?
Yeah. So some of the things that came out very concretely from this discussion was that one other presentation was from E4 Engineering, where they spoke about an open instruction set architecture, like a RISC-V based architecture. So this was a promise of an accelerator that's actually cheap because you don't have a restrictive IP on it. And the presenter demonstrated huge energy savings there. And this kind of experimental hardware is something that we could acquire as a few nodes and potentially have some scientific applications tested on it. Likewise, IQM, another presenter, showcased a real-world quantum accelerator that works as a hybrid with classical computers. So they already deployed that in another supercomputing center in Germany, and they're open for new partners for topics like this.
So let's say that we have opened the door. Now we have to make sure that this door remain open and the dialogue will continue. So
100%.
Good luck then for this new endeavor, and see you next year at PASC26.
Thanks a lot. Thanks a lot.